Let's title it Chemistry A Final Review Sheet, and this is part 2. Now we left off on the atom. So the atom has something in the middle, and what's that called? The nucleus. Good. And around the nucleus is what? Electrons, right? Use this model above. Inside the nucleus there are 2 parts. Who remembers what those parts are called? Protons and neutrons. Good. Protons have what kind of charge? Positive. And neutrons have what kind of charge?
Zero.
Nothing. Zero charge. Right? So when those 2 are together, the nucleus can stay together. Otherwise, positive and positive will fly apart. Now, there are theories of what atoms look like. And we're going to start with the first one. Now, the solar system has what in the middle?
Sun.
The sun. So I want you to draw a circle or an oval. Label it the sun. And around the sun is what planet? What's the first and closest planet to the sun? Remember? Starts with the M. Mercury. Mercury. Right? And after Mercury, we'll just do 3 planets. What's after Mercury? Venus. Good. So Venus we'll put over here. And last but not least is what? Earth. And let's place Earth over here. So a scientist, a chemist, when they knew about the solar system, he thought that's how atoms are like. Because in the middle are protons and what? Neutrons, right? And they're together keeping things stable. And around this nucleus are what? Electrons. So let's draw the atom. So draw a cluster. It could look like grapes or some sort of candy. And then darken in some of these circles so that you know that there are some protons and neutrons. They're all different. And then around it are rings. Maybe 3, maybe 4. And they are electrons. And we'll just use the letter E to represent that. Now, do these look alike? Do they look similar? The solar system and atoms. They do. That's why they call this the planetary model. The planetary model. And this is the solar system. Now the person who came up with this is Niels Bohr. The planetary model from Niels Bohr. But they found out he was wrong. Atoms are not in rings. It just doesn't make sense because negatives and negatives, they don't follow each other. There's no attraction. What do negative and negative want to do? They want to repel. They want to bounce away. So in theory, this planetary model wouldn't be in circles. It wouldn't look like this. It's too nice. It's too neat. It's too perfect. Negatives and negatives, they fly all over the place. So another chemist decided, okay, let's guess where the atom has electrons. We can't know where it is in a ring, but we can guess. So there are areas of guessing. Areas of guessing the electron called orbitals. Areas of guessing called orbitals made more sense. than the planetary model. Planetary model looks nice, but not realistic. So let's draw several orbitals, areas that we guess, called area of probability. The first level is not called level 1. It's called level 1s. Now this should sound familiar because it's electron configuration. But the first level is 1s. The second level is 2s. The third is 2p. Let me erase this. P, and then it's 3s, and then it's 3p, and we'll stop there. So if you have one electron, it's going to be in this first orbital, area of guessing. If you have two electrons, it'll also be in this area of guessing. So 2 electrons at the most can stay in this first level. The second, how many can fit in there?
2.
Also 2. And the third, 6. And the next one, back to 2. And the fourth one, 6 electrons. Now you might ask, why is it 2, 2, 6, 2, 6? There's no logic to it. You know, is it just their favorite number? Were they born on 2, 2, 6? The answer is the s orbital has one shape holding 2 electrons. The p orbital has 3 shapes. S orbital has one shape, and the p orbital has 3 shapes. Now, let's make it bigger and bigger because that's what this number tells us. The higher the number, the bigger the orbital. So 1s, let's make it bigger. Let's make it more realistic. It goes 2s and 3s would be even bigger. Kind of like small, medium, large. And each one holds 2 electrons. 2, 2, 2, 2, 2, 2, 2, 2, 2. Now, if atoms look like orbitals, then they're not going to look anything like a planetary model. It's just going to be a mix of all of these combined.